Good morning to everyone. Today we will discuss regarding Werners coordination theory. Okay, na? So in this theory, Werners uh, uh, explained regarding this theory. Okay, na? So Werners put forward his famous theory of coordination to explain the bonding in coordination compounds. So there is a bonding between the coordination compounds between the metal and ligand. The bonding in coordination compounds. This theory explained regarding this. Okay, so he was awarded Nobel Prize for the chemistry subject in the year 1913. In the year 1930. So that's why for this theory, and he is rightly called as the father of coordination chemistry. The Werner is nothing but what? He is the father of coordination chemistry. So in this theory, Werner was able to explain. So Werner was able to explain the nature of bonding in the complex. So the nature of bonding. So what is the nature of the bonding in the complex? So we'll go for some of the important postulates of Werner coordination theory. So generally, the metal atom exhibits two types of valency. We can see two types of valency in the coordination compounds according to the Werner. So there is a primary valency and also a secondary valency. Primary and secondary valency. Okay, na? So first we'll go for the primary valency. In the primary valency, first point, it is ionizable. The primary valency is ionizable and it is non-directional. It is non-directional. The primary valency is nothing but is the number of charges on the complex ion. It is nothing but is the number of charges on the complex ion. So it corresponds to the oxidation state of the central atom. Nothing but what? It is the oxidation state of the central atom. Okay, now in this, the first thing we should remember, it is ionizable, and second thing we should do, it is a non-directional. It is nothing but what? The oxidation state of central atom. Okay, so next will also generally this primary valency, it is represented with dotted line. Generally it is represented like dotted line. It is represented as dotted line. So next we'll go for the secondary valency. So in the secondary valency, it is non-ionizable. It is non-ionizable and it is directional. It is having some directional, that's why we call as directional. Generally the secondary valency is equal to the number of ligand atoms. The number of ligand is nothing but what? It is corresponds to the coordination number. It is corresponds to the coordination number. So this secondary valency is represented with thick line. This is a thick line. Generally it is represented with the thick line. Okay, na? So generally according to Werner, there are two types of valency, primary and secondary. Okay, so next, each metal atom has a fixed number of secondary valency. That is nothing but what? Fixed number of coordination number. Okay, so generally this metal ion tend to satisfy both primary and secondary valency. Generally this primary valency is satisfied only by negative ions, only satisfied by negative ions, but secondary either satisfied by the negative or neutral molecules, but the secondary can be satisfied by negative or neutral ligand. So in this you can understand the negative ion may satisfy both the primary and secondary. Okay, so next we'll go for the another point. So in this, so you can see here, so in this you can see here, so the secondary valency or directional or directed towards a fixed position in space. Why? Because it generally is as a directional and non-ionizable. Just now we discuss. So by this, so we can define the geometry of the coordination compounds. We can define the geometry of the coordination compounds. Yes or not? Okay. So in this, suppose if the uh, coordination number is 6, maybe the structure may be octohedral. If the coordination number is 4, the structure may be either tetrahedral or square planar. So by this secondary valency, thus determine the stereochemistry of the complex. So we can discuss the geometry of the complexes. Okay, so Werner explained this theory by taking an example. This is nothing but what cobalt amine complexes, by taking the example of cobalt amine complexes. So generally we can see it is represented like this. So these are the stoichiometries of the complexes. Total how many we are showing as 4. Okay, we can see in this the metal is cobalt, CO, and the ligand we can see two types of ligand, Cl3 and 6NH3, nothing but what it containing chlorido ligand. So not Cl minus is nothing but what chlorido, and there is also another ligand, it is nothing but what NH3 ligand. NH3 is nothing but what amine ligand. So there is a chlorido ligand and also amine ligand. Two types of ligands are seen here. Okay, so next, generally this is a stoichiometric of the complex. We'll write in coordination, like we'll represent in coordination compounds. We'll write the formula for this given examples. Okay. So next we'll go for how to represent this one. So first we'll go for COCl3 6NH3, COCl3 6NH3. Okay, so in this you can see here COCl3 6NH3. so in this so this is first we can write this one, the first one COCl3 6NH3, we can write represent as like this. So within the square brackets we are writing only the amine, the Cl3 is writing after the square brackets. So this is a compound. Then the IUPAC name of this compound, I think just now we discussed IUPAC name in the previous class. Here it is nothing but what hexaamine. Yes or not? Hexaamine cobalt is a bracket load 3 chloride. Yes or not? This is IUPAC name of this compound. Okay. Na? So in this, the generally what will happen on ionized, so this will comes under positive, this 3Cl minus comes under negative. Okay na? So when reacting with what AgNO3 silver nitride, when reacting with AgNO3, what will happen, this Cl3 minus react with AgNO3. So 3Cl minus are present, there is a formation of 3AgCl, there is a formation of 3AgCl precipitate, AgCl precipitate. Okay na? So in this we can see totally how many amines are there, 6. So the 6 amine ligand form coordinate bond to central metal ion cobalt. Okay na? And forming a complex ion, so this is a representation for the first one. Okay, you can see here there is a central metal. So total how many amines are there here, 6. So generally these amines are nothing but what secondary valency. Generally the secondary valency are represented with the thick lines. The secondary valency always represented with thick lines. And 3Cl3, okay, now this is representing as a negative what generally is primary valency. This primary valency are represented by dotted lines. Primary valence is represented by dotted lines. Okay na? So this is the first representation. So next we'll go for the another one, the second one COCl3 5NH3. Okay na? So in this what will happen, so we can write the complex like this. How we can write, we'll write CO. Okay na? So 5NH3, 5NH3 is nothing but we can write one Cl inside, then we can write here NH3 5, NH3 5 within the bracket and close the bracket, Cl2, Cl2. Okay na? So in this you can see the cobalt here, total how many amines are there, 5 amines, 1 2 3 4 5. So these 5 amines are acting as what secondary valency, but Cl2 which is present, this is acting as a primary valency, Cl2. And inside Cl chloride is present, so this is acting as satisfied both primary and secondary valency. It satisfies both primary and secondary valency. Okay na? So when reacting with what AgNO3 silver nitrate, so what is there here? Cl2. Cl2 is nothing but what? So when reacting with AgNO3, it gives rise to 2 moles of AgCl precipitate. 2 moles of AgCl precipitate. So this is the representation of second one. Okay, you can see. I think all of you understand. So next we'll go for the another one. Okay. Hmm. So in this you can see MIL. So just now we discussed this point is regarding what second one. This is just now we discussed this one. Okay. So next we'll go for the third one. So COCl3 4NH3. So we can represent this one as how many amines? Only 4. So that's why we're writing Cl2 4NH3. Okay. So next after that we can write this is a representation of this one. Total how many chlorines? 3 chlorines. 2 are inside and 1 is outside. Okay. So in this we can see totally 4 amines. These 4 amines are nothing but what? Secondary valency. And inside how many chlorides or chloride is present? 2 are there. So that's why these 2 are represented as satisfying both the primary and secondary valency. But the chlorine which is presenting outside the coordination sphere, it is representing only as primary valency. Okay. So when it is reacting with AgNO3, it gives only 1 mole of AgCl precipitate. Only 1 mole of AgCl precipitate. Why? Because I think only one Cl minus is present. Okay na? So in this what will happen? 4 amines and also 2 chloride will form a coordinate bond to the central metal ion. Okay na? This is the third one. So next we'll go for the fourth one. So in this what we'll observe here, the formula is COCl3 3NH3. So we can write the formula, we can represent like this: COCl3 and H3 3. Okay now. So in this the amine 3 amines are acting as a secondary valency, and the 3 chloride is acting as a secondary and primary valency. Okay now. So when reacting with the AgNO3, Ag AgNO3, so there is a no formation of precipitate. So no PPT. So there is a no formation of AgCl precipitate. No formation of AgCl precipitate. Why? Because so the outside the coordination sphere there is a no chloride. So by taking this cobalt amine complexes, Werner explained regarding the primary and the secondary valency. So just now we discussed the primary valency is nothing but what? Ionizable and non-directional. There are nothing but what? Oxidation state of the central ion. Generally this primary valency is represented with the dotted lines. So next we will go for the secondary valency. The secondary valency are nothing but what? Uh, it is non-ionizable and directional, is represent the coordination number, so not, or number of ligands. Generally it is represented with thick line. So when I explained by taking the example of cobalt amine complexes. So it is also by the Werner then attempt to find the shape of the complex. To find the shape of the complex. If the coordination number is 6, the shape may be either like this. You can see the shape may be either like this: planar hexagon or trigonal prism or octahedron. Okay na? So but what will happen here by later by X-ray structure, determine this, the when the coordination number is 6, the structure is only octahedral shape. So mx6. So this is nothing but what? 6. The coordination number 6 for the structure of this complex is octahedral. So in this we can see only one form. Okay. So instead of writing mx6, we can write mx5y. One of the x ligand is replaced with y ligand. So here also we can also write only one form. Okay. So next we'll go for another slide. If it is suppose like this, here you can see here mx4y2, and nothing but two of the x ligands are represented with ligands. So here this x are present like this. Okay, now it is nothing but what 1, 2 position. So this comes under a cis. It is in opposite side. Generally this y, it is comes under trans. So for this type we can see two types of isomers. One is cis and trans. So next we can write like mx3y3. So x3y3, x is 3 and y is 3. Here also the coordination number is 6. So 3x ligands or 3 y ligands which is present on same side. So that's why we called as facial. Okay, now here but it is not present on the same side. We see y opposite. Generally we call as meridional. Okay, now here also we can see two types of isomers. So this is regarding what the coordination number 6. So next we'll go for the coordination number 4. If the coordination number is 4, the structure may be either geometry, maybe either it may be an octahedral or it may be square planar. Either it may be octahedral or square planar. So in the octahedral we cannot see any isomer, just only one structure is there. But in the square planar we can see two so one is cis, the another one is trans. One is cis and another one is trans. So we can see this is an example for square planar. So just we write the, suppose here the similar groups which are present on same side, generally we can write cis. If the similar groups which is present on opposite side, generally we can write as trans. So generally these isomers are seen in only in square planar. Suppose for tetrahedral, this is a structure of tetrahedral. Yes or not? So this is a structure of tetrahedral. So in this, so we can only one isomerism is possible. Only one. So there is a no trace cis and trans for the tetrahedral. So this is regarding awareness theory. Okay. I hope all of you understand. So this is a representation so this first one you can see. So this is nothing but what CO NH3 6 Cl3. So this is the diagram for the first one. Okay, so next we will go for here. This is for second one. So this is third one and this is the fourth one. So you can see here this chloride is acting as a primary valency. Here the chloride here it is acting as a primary valency, but here it is acting as a primary and secondary valency. Here you can see it is acting as a primary and secondary valency. Here we can see all the chloride is acting as a primary and secondary valency. So generally this secondary valency is represented with dark and the primary is thick. Okay, so this is just showing the diagrammatic representation. Okay, so this is again some points regarding the same repetition part. So example to clarify regarding the Werners theory. Okay, thank you one and all.